We're looking at 11.2, graphing trig functions. And let's focus first on the sine graph, then we'll get into all this terminology. So how do we graph y equals sine of theta? If we go back to the unit circle, and we don't even have to count every 30 degrees or every 90, or I'm sorry, every 45 degrees. We can just count by 90s. If we focus on here, knowing what x, y, and r are, since we're talking about sine, let's just focus on y and r. Over here, y is 0 and r is 1. 0 divided by 1 is 0. So at 0 degrees, we know the y value is 0. If we jump up here to 90 degrees, or pi over 2, here y is 1 and r is 1. 1 divided by 1 is 1. So sine of pi over 2 is going to be 1. If we go over here to pi, over here y is 0, r is 1. So sine of pi is going to be 0. If we go down here to 3 pi over 2, y is negative 1, r is positive 1. You divide those, you get negative 1. Then you get back here at 2 pi, you get 0 over 1, which is 0. Now just looking at that may not really tell you what this graph looks like. We know that it's going to come up here and come down here. And if I just leave these points, you might think that that's just going to be linear. It isn't. So let me just add some more points here to see if we can get a better idea. If we go, let's say, let me move this fella, 30 degrees, which is pi over 6. Y here would be 1, and R would be 2 if I was doing a 30, 60, 90 where I wasn't really concerned about the unit circle being 1, the radius. So regardless, whether you're thinking about the purest way or not, sine of pi over 6 is going to be 1 over 2. So pi of 1 over 6 would be about here, and a half would take me here. Then if I go to 45 degrees, or pi over 4, there, x and y could be both 1, and r is going to be the square root of 2. So that's 1 over the square root of 2, and 1 divided by the square root of 2, that is about 0.7. Maybe right there. Then if we go up here to pi over 3, which is 60 degrees, we're going to find that y is square root of 3 and r is 2. Square root of 3 over 2, that is about 0.87. So hopefully you can see that this is curving, like so. And if we continued over here, we would find that it's curving just as gently down, and then it's curving up, like so. This represents one period of sine. A period is the distance along the horizontal axis that the function must travel before it repeats itself. So this curve that you see right here, that I just graphed, let me delete this here. If I took this and I copied it and pasted it, I could continue to draw this as many times as I wanted. Let me just add just a little bit more here to this. This is a good representation of what the sine graph looks like, where this here we would call one period. Let me write that down. 2 pi would be the period, the horizontal distance that this sine graph travels before it starts repeating itself. Some of this other terminology, a periodic function is a function that repeats itself over regular intervals. And the sine graph is definitely periodic. A midline is the horizontal line that runs halfway through the maximum minimum value. So this is a max, this is a min. Halfway through, that's going to be through here. This is the midline at y equals 0. The midline is a term that's unique to sine and cosine. Amplitude is the height from the midline to the minimum or maximum. So the height here is 1, the height here is 1. So this would be the amplitude from here to here. That amplitude is going to be 1. So this is the sine graph. What's the domain of this? It's all real numbers. What's the range? It goes as low as -1 and as high as 1, inclusive. Period. It's the horizontal length. It repeats itself, 2 pi. The amplitude is 1, and the midline is 0, y equals 0. The midline is how far up or down you go from this midline. Now that you know what sine looks like, let's focus on what cosine is going to look like. And we're going to base cosine on sine. So the first thing I'm going to do is I'm going to just quickly copy sine over here, and I'm going to do it, let's say, in this gray. So sine starts on the midline, quarter of the way through, it's 1 above, halfway through, it's on the midline, 3/4 of the way through, it's below, and then it's back to the midline. So this is sine. It's not what we're graphing here, we're graphing cosine. But the relationship between sine and cosine is that if we shift sine 90 degrees to the left, or pi over 2 to the left, that's going to give us cosine. So sine of theta plus 90 degrees, well, that equals cosine of theta. And we typically use radians, not degrees. So I'm going to say sine of theta plus pi over 2 is equal to cosine of theta. Now, if you remember, when you're adding or subtracting on the inside, that's going to move the graph horizontally. And if it's a plus 90, it goes left. If it was a minus 90, it would go right. So if we just take each of these points that we see here on sine and shift them to the left, pi over 2, we would get these points. So I'll make sure it's clear what I'm doing. We shifted each of these points to the left. Whoops. I'm not doing a good job with that. Let me not add that. Let me do this. We move this point to the left, 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 this point to the left. If we connect those points, then we'll see this red curve. This is what cosine looks like. Cosine is also periodic, so it repeats itself. So the next point is going to go up, and then it's going to come back down again. It's going to come back up forever. This red curve is the cosine graph. The gray curve is the sine graph. Once again, the relationship between sine and cosine is just the sine graph shifted to the left 90 degrees. You could also discover cosine using the unit circle. Instead of y over r, you use x over r. The domain for this is all real numbers. The range, -1 to 1, both inclusive. The period is 2 pi, the amplitude is 1, and the midline is y equals 0. It's the same graph as sine, it's just translated to the left, pi over 2. To find tangent's graph, I'm going to take sine and cosine, and I'm going to graph those fellows over here. Now, both of these are going to be not part of the actual graph. So let me change these to dashed. It's not really what we're looking for. We're going to use this to find our answers. Now, we know from our study of trig that tangent of theta is the sine of theta divided by cosine of theta. So for us, let me color code this. That's going to be the gray divided by the red. Let's pick out some key points so we can figure out what this looks like. If I take, let's start here. If I take 0 divided by 1, I'm going to get 0. So I know that tangent of 0 is 0. Let's pick this point right here, which ends up being pi over 4. But you don't actually have to know that to be successful with this. But this point right here, whatever it is for sine and cosine, it's the same number. They're intersecting there. If you take a number and divide it by itself, you're going to get 1. So that means that where those points intersect right there, that's going to be a y value of 1. Now we know that's true because sine of pi over 4 is 1, because pi over 4 is a 45, 45, 90. X and y are both the same value. So if you divide 1 by 1, you get 1. We're continuing to divide sine by cosine. At pi over 2, sine is 1, cosine is 0. What's 1 divided by 0? 1 divided by 0 is undefined because tangent has a vertical asymptote here at pi over 2. Let's say we go here, which is pi. If we take 0 divided by negative 1, we're going to get 0. So we're back here. If we come over here to 3 pi over 2, we've got gray, which is negative 1. 3 pi over 2, the y value is 0. 1 divided by 0 is undefined. I have a vertical asymptote here. So it looks like we're going to have a vertical asymptote every 90 degrees here. So what's happening in between? We know we got this point. I started this with green. Let's make this black here. And I know that these points connect something like this, which is going to be the same here because this is also a periodic function. Well, what's happening over here? Well, at halfway between pi over 2 and pi, which would be 3/4 pi, think back to the unit circle. At 3 pi over 4, the reference angle here is pi over 4. Y would be 1, x is negative 1. Tangent is y over x, that's negative 1. So that means that this is what the curve for tangent is going to look like. It's kind of like the function y equals x cubed. So that means it's going to be the same over here, like so. Since this is periodic, these vertical asymptotes are repeating themselves every pi. So that means we're going to have another vertical asymptote here at negative pi over 2. So what's the domain of tangent? And I'll get to that in a second. What's the range of tangent? Well, it's going to go from negative infinity to infinity, all real numbers. What's the period length? Let me just temporarily erase sine and cosine here, just so we can not get overwhelmed with all the extra stuff that's here. Our period length here is going to be pi. It's the horizontal length for this little fella repeats itself. That's not the domain. Let me move this up. Tell you what, let me get rid of that. It looks like that's part of the graph. Let's make this green. We got pi from here to here. So the period is pi, which is half of what it is for sine and cosine. The domain is everything but these vertical asymptotes. So we'll write this as all reals except x cannot be. Pick out one of the vertical asymptotes. We got one here at pi over 2. Plus how far apart are the vertical asymptotes? They're pi apart. So we have to account for all of them. So we'll say pi times k, where k is an integer. So that is the domain for tangent. Notice I didn't ask for amplitude or midline for tangent because those are terms that are reserved exclusively for sine and cosine. On the flip side, I'll tell you what, I'm going to copy these graphs just so I'm not going to copy them down. I'll just draw them real quick. Graph of sine, once again, we know looks like this. Whoops. Cosine is the same graph. It's just translated to the left, pi over 2. So it looks like this. Tangent is dividing sine divided by cosine. Once I get started, it's pretty easy to figure out. So 0 divided by 1. So I'm starting out here at 0. And then at pi over 2, I've got a vertical asymptote. 3 pi over 2, I've got a vertical asymptote. Negative pi over 2, I got a vertical asymptote. And in between, I've got these shapes that resemble but are not x cubes. Resemble are not actually x cubed. So there's sine, cosine, and tangent. Cosecant is the reciprocal of sine. So let me copy the sine graph down here again. And you can do that by memory as you get better at this. So if I take each of these y values and reciprocate them, that's going to be cosecant. So this is 0. 0 reciprocated is undefined. So cosecant has a vertical asymptote. If I go here at 1, 1's reciprocal is 1. If I go to pi, its y value is 0. Reciprocating that is undefined. 2 pi is at 0. 0 reciprocated is undefined. 3 pi over 2 is negative 1. That reciprocated is negative 1. If you were to fine-tune some of this, pick some test points between 0 and pi over 2, you would find that our curve looks kind of like a parabola. This pattern repeats itself for the duration of this graph. The gray part we're using as a baseline to help us graph this. That's just the sine graph. The domain is everything but these vertical asymptotes. So all real numbers except x cannot be. Pick any vertical asymptote you want. I'm going to pick the 0 plus, how far apart are they? They are pi apart times k, where k is any integer. The range, the graph goes from 1 up forever and from negative 1 down forever. So the range is going to go from negative infinity, we start from the bottom and work up, to negative 1 inclusive, in union with 1 inclusive to infinity. The period, the horizontal length of this graph, before it repeats itself, is 2 pi. Let's check out secant. Secant is the reciprocal of cosine. Cosine is like sine, but it's translated to the left 90 degrees. So it looks something like this. So if I take secant and reciprocate each of these key points, here, 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 and here, every 90 degrees essentially. Pi over 2, negative pi over 2, that y value is 0. If I reciprocate that, I'm going to get undefined. It's a vertical asymptote. I'll just do all the ones that are 0. Reciprocating 0 is going to be undefined. Those are vertical asymptotes. And then every one of these that are 1 or negative 1, reciprocating 1 is 1, reciprocating negative 1 is still negative 1. This is the same graph that we see over here, cosecant, it's just translated to the left 90 degrees. Each of these points represents something that resembles a parabola. It doesn't look like it's the same scale, but these are essentially the same size. Not essentially, they're exactly the same size. This was drawn to scale. So this domain is all reals except x cannot be, I probably should be using thetas here instead of x's, since we had thetas here. But what's done, it's done. Take my first vertical asymptote. I'm going to pick pi over 2, that's the positive one, plus, how far apart are these fellas? They are pi apart times k, where k is any integer. Range is the same for cosecant, and so is the period. The range goes from negative infinity to negative 1, inclusive, and from 1 to infinity. 1 is also inclusive there. Cotangent, almost done here. If we know what tangent looks like, which we have it up above, tangent has a vertical asymptote at negative pi over 2. Reciprocal of that's going to be 0. Then at 0, we've got a y value of 0. If you reciprocate that, you're going to get a vertical asymptote. And then we have a vertical asymptote at pi over 2. Reciprocal of that is going to be 0. And then at pi, we're going to have a vertical asymptote. You can see this pattern. And at 3 pi over 2, it's going to be at 0. 2 pi over 2 is going to be a vertical asymptote. And what do these curves look like that go through these points? Well, this is a negative number here between negative pi over 2 and 0. If I reciprocate that, it's still going to be negative. Essentially, what this is going to look like, it's like the reverse of the curve for tangent. Reverse meaning a vertical reflection. Or you could think of it as a horizontal reflection for each of these curves. The domain here is all reals except x cannot be 0. That's where this first vertical asymptote is. Plus pi times k, where k is any integer. This pi comes from the fact that these vertical asymptotes are pi apart. The range is all real numbers, goes up and down forever with no breaks. And the period for this is pi, just like tangent. So these are the 6 parent graphs. They are all based upon you knowing what sine is. Cosine is translated to the left, pi over 2 units. Tangents dividing sine over cosine. Reciprocal, reciprocal, reciprocal. All right, that concludes 11.2. Your homework is to do one of each of these, I believe. Thank you for paying attention. Have a good